Hi, I'm Professor David Farina. In today's lecture, we're going to be discussing the Earth and its moon, in particular, Earth's magnetic field. Let's get started. So the Earth's magnetic field, what is it and how is it formed? That's a great question, and it's something that we are just starting to get a really good handle on. And it's going to become more important as we start to try to travel to other worlds in our solar system, and we'll get into that today. So the Earth's core is mostly iron and nickel, as we've discussed in previous videos, and because of this iron and nickel core, it can conduct electricity. Secondarily, the outer core of Earth, made of also iron and nickel, is a liquid. So we have an inner core that is solid, we have an outer core that is a liquid, and the liquid actually can travel around in motion, and as a result, we've got the magnetic induction being created. It's almost like an electric motor or a generator. And magnetism and electricity are actually both the same thing. The electromagnetism forces that are involved here can produce an electric field, but they can also produce a magnetic field as well. So what's occurring here is what we call a geodynamo. And you'll notice that Earth's magnetic field actually is offset slightly from our rotational axis. So this does not have to be directly related to the rotational axis of a planet. It can actually be offset from that point. And so when you use a compass, you're actually getting magnetic north, not true north. True north would be the North Star. Currently, the North Star is Polaris. It's about 1 degree from the rotational axis of Earth. The magnetic field of Earth is not the same. So, zooming out a little bit, the Earth's magnetic field, or magnetosphere, does interact with the sun's solar winds. And so, in this diagram, here's a direction towards the sun. You can see the solar winds are coming in, and they're impacting the Earth's magnetosphere at a point called the magnetopause, where the Earth's magnetic field is no longer interacting. It's no longer here. And so, you'll notice that we have field lines drawn from the south moving into the north. And we'll notice also that this side is kind of this circular shape, and on the other side it's kind of like trailing off to a tail. So this has to do with the way that the Earth is moving through the solar winds. In the Earth being pointed this direction toward the sun, we always have this edge being kind of the rounded side or bow shock, and the trailing edge always points directly away from the sun. Now, as particles interact with magnetic fields, they can become trapped on those magnetic fields because the sun's solar winds are charged particles, or ions. Ions can travel along an electric field or magnetic field, and these Van Allen belts are areas for which there is a large concentration of these charged particles. Now, as I said earlier in the video, this may become a major issue for us as Earth is starting to, Earthlings are starting to explore other places in our solar system, because the Van Allen belts are actually a pretty dangerous place to travel through. So if you're going to be on a spacecraft and you're going to travel through the Van Allen belts, you need to consider that you're being impacted by large amounts of ionizing particles, which can cause cancers. And as you leave the Earth, you also are going to travel in interplanetary space, where there are no magnetic fields to protect you, and so you're susceptible to the sun's dangerous radiation. This is something that you would consider when you go to the moon. it's something that you want to consider if you want to go to Mars or elsewhere. So something that we will have to solve moving forward in our exploration of our solar system with humans. So I just wanted to highlight once again how this looks from a zoomed out perspective. We got some other information here. That bow shock once again is on the front. Our radiation belts, those Van Allen belts, are indicated here, and we can see how this can also produce aurora. So aurora, or the northern and southern lights, are produced as the magnetic field comes in at the north and south pole. In the North Pole, you have the northern lights, or aurora borealis, and in the southern hemisphere, you have the southern lights, or aurora australis. So borealis in the north, australis in the south. And they are absolutely magnificent. So what basically is happening here is that the Earth's atmosphere is being directly impacted by these charged particles, and as a result, the atoms in the atmosphere are becoming excited or ionized, and as they have their electrons being boosted to higher orbitals, you basically have energy being put into the atom that is no longer in what's called a ground state, and when those electrons drop back down to a ground state, they release a photon of light, which we see as the beautiful colors in this picture. So thanks a lot for watching The Earth and its Moon, Earth's Magnetic Field. I hope you learned something from this video. If you did and would like to learn more, please hit that subscribe button. And if you'd like to get a notification each time I make a video, please click that bell at the bottom. Thanks again. Keep on watching.